Hello everyone, welcome to iExamB. You may subscribe to the channel and press the bell icon so that you do not miss updates on our upcoming videos. Here we are on day number 9 in this series of 50 days, 50 questions. I hope you are enjoying the series and getting your concepts clear every day. So let's start with the question for day 9. Here the question on my screen is, any straight line supply curve that intersects the vertical axis above the origin has an elasticity of supply equal to 1, greater than 1, less than 1, 0, or there is insufficient information to answer this question. If you know how to solve such questions, pause it. You should also know the proof of why it should hold and then come back to the video. So if you don't know, let's see how do we solve such kinds of questions. So here we have to find out the elasticity of supply. Okay, and we will take a general supply function and see what happens to the elasticity of supply. So see, this is the supply function. Qs is equal to A plus Bp. There is a positive relationship between the quantity supplied and the price. That's why this is how I can write a supply function. Also note that in terms of price, why I'm taking it in terms of price, because you plot prices on the y-axis whereas quantities on the x-axis. So whenever you have to write an equation in standard form, you write it like y is equal to mx plus c, right? So that's why now I'm taking the this equation in terms of price. In terms of price, this is going to be qs minus a upon b. This is so this implies that the slope of the supply function is equal to 1 upon t. Okay, the coefficient of qs is my slope. Now also note that the elasticity of supply is given by delta q upon delta p times p by q. And this delta q upon delta p, this is nothing but the inverse of slope. So I can write this as 1 upon slope times p upon q, which is equal to, because the slope is 1 by b, elasticity would be equal to b times p upon q. Now substitute q as this function here in this equation. We have dt upon a plus b. This is your elasticity of supply. Now depending upon what values a is going to take, your elasticity of supply will be determined, because Bp in the numerator and denominator are same. So it all depends upon the value of A. So there are three possibilities. If A is negative, that is if A is less than 0, this would mean what? That your y-intercept. Y-intercept, what is the value of y-intercept? See this equation. You know the value of y-intercept here is minus A upon B. Okay. So if A is negative, then this y-intercept, negative, this will become positive. Okay, so positive means that the elasticity of positive means that your supply curve would be originating above the origin, right? And the elasticity of supply value, if A is negative, right, so less than 0, this would mean that the denominator would be less than the numerator. So elasticity value would be greater than 1. Okay. Similarly, if A is greater than 0, your y-intercept value, which is minus A by B, is going to be less than 0. If it's positive, then this whole value will be negative. This would imply that your curve is starting from somewhere here. Okay? And your elasticity value, if this is positive, then this is going to be less than 1. Similarly, if A is equal to 0, your y-intercept, this is also going to be 0, and your elasticity of supply would be equal to 1. This value will be equal to 1. This is 0. Right? So this would mean, and y-intercept being 0 means that your curve is starting from somewhere here. So we have discussed all these three cases, whether if the curve intersects at the vertical axis, which is this first case, then your elasticity of supply is greater than 1. Hence, the right answer here is answer B. I hope you have understood. Now, if the question asks you that if the elasticity of what is going to be the elasticity of supply value. If your supply curve originates from the x-axis, then you can clearly say that it's going to be less than 1. If it starts from origin, then it's going to be equal to 1. For more such questions, attempt the mock test on our website. You can also watch the playlist for 50% faster preparation. Thank you. Keep preparing.